Hey guys, my name's Abid, and today I'll be walking you through question 7, closet overhaul. Let's get right into it. So you've designed a closet abstract data type to help you organize your wardrobe. And a closet contains two things. One, it has an owner, so that's the name of the closet owner, represented as a string, and it has clothes, which is essentially a collection of clothes in the closet represented as a dictionary. Now, this dictionary has, recall the dictionaries have key value pairs. So the keys in this dictionary are the names of the clothes, and the values corresponding to those keys are the number of times each of those clothes has been worn. So let's get into the specifics here. So the make closet constructor takes in an owner, which is a string, and clothes, which is a list of strings representing the clothing items. And it returns a closet ADT. So here's what we've been given, right? So we're given this constructor here, takes in this owner string and this clothes list, and basically creates this clothes dictionary. And for every item in the clothes list, it will just add those clothes to the dictionary as keys. Because remember, the keys are the clothing item names. And then it initializes those keys, or the values corresponding to those keys, to 0, because none of the clothes have been worn when you first create the closet ADT. And then it returns both the owner and the clothes dictionary in the form of a tuple. But we are not going to directly manipulate that tuple in our code because we don't want to violate the abstraction barrier. So that's the main thing. But yeah, then we have a get owner method, which makes sense because we don't want to violate the abstraction barrier when we're writing our code. So they give us this function that returns the owner of the closet, and then similarly they give us something that returns the dictionary of the clothes in the closet. Okay, so given this ADT, our job is to implement the functions where clothes and favorite clothing item. And we can, so first things first, we're going to implement where clothes. So where clothes takes a closet, and a list of clothing items, clothes worn, and increments the number of times each item is worn by 1. If the clothing item, if the clothing item specified does not already exist in the closet, then we have to add it to the closet. So how would we go about doing that? So first things first, we can start by just defining. I suppose I'll just answer this question up here with this space, but I'm just going to write out the definition here that is given to us. You see, define where clothes, which takes in closet and clothes worn. Cool. So let's just look through the doc test to get a better idea of how this function works. So here, as you can see, we create a new closet called Atom closet, and we use this make closet constructor here, and the owner is Atom, and the list of clothes here, and we're passing in polo, tie, and shorts for this list of clothes. And then we're going to call the where clothes function, which is what we're writing now. So after we call that function on this closet and this list of clothes here, what we're going to do after we get the clothes, you'll notice that we're going to increment tie's value by 1 because it appears once in this input list. And we're going to increment shorts's value by 2 because it appears twice in this input list. And notice that polo remains 0 because that's what we initialized it to when we made the closet. And we did not wear the clothes because we did not specify that in the input to this function. Cool. So how can we go about doing that? Well, a good place to start is to first somehow get the dictionary of clothes, right? We need to update that somehow. So I propose that we just create this variable clothes, and we need a way to get the dictionary. Is there something in the given skeleton code that will get us the dictionary. Yes, there's the get clothes function. And all that does is that you just call get clothes on a specific closet. In this case, the closet is given to us. It's the argument closet. And that, that'll return the dictionary of clothes. And we're going to store that in our clothes variable. So next up, we are going to need to somehow go through the clothes worn list. And every time we see an article of clothing in there that already exists in the dictionary in our closet, we're going to basically increment the value of that article by 1. And if it doesn't exist, we're just going to, if it exists in the clothes worn list but doesn't exist in our dictionary, then we're just going to add it to our dictionary. So I think whatever we're going to do, we're going to be iterating through this clothes worn argument. So I think a good place to start now would be to just say for C in clothes worn, right? We want to basically cycle through all of the clothes we wore. Now we want to basically do one thing, right? We want to say, before we go about incrementing anything, right? We first want to do a check to see if that article of clothing that we're currently on in this loop is in the dictionary, right? Because if it's not, then we're going to have to add that article to the dictionary. So how can we check whether some object or some item in this, some element in this iteration is in our dictionary? Well, if you recall, there's an in command, and you can basically see if some element is in a dictionary using the in syntax. So you can say if C, which is the article we're currently on, not in, right? Because in the case that it's not in our dictionary, which we called clothes, then what are we going to do? We're going to create a new key value pair with the key being this article and the value being 0. And the syntax for that in Python is just clothes, and then like it's this array square bracket syntax here at C, which is the article, that's the key, is going to equal some value, and that's 0. Cool. So that's that weird case. And now what? So besides that, if it's not there, add it. But if it is there, what are we going to do? We're just going to increment its value by 1. And the way we do that is using this. We basically want to get the value associated with this key C, and then we want to increment it plus equals 1. And that's how you'd go about implementing where clothes. Yeah, hope that helped. And let's move on to part B now. Hey guys, I'm back, and today we'll be answering part B. So part B asks us to implement favorite clothing item, which is this function that takes in a closet, basically the same closet abstract data type that we defined earlier in the question, and it returns the name of the most frequently worn clothing item, assuming that there are no ties. So recall that every closet has a dictionary data structure that keeps all of the articles of clothing in that closet as its keys, and then corresponding to those keys is a value, or to each key is a value representing the number of times that article of clothing has been worn. So essentially what this question really comes down to is us finding the key in this dictionary with the largest value, or like with basically the piece of clothing that has been worn the most times. So there are many ways to do this, but this problem gives us this max function in the skeleton. And that kind of tells us that, well, we're going to have to use the max function somehow. If you recall, max goes through an iterable and outputs the maximum value in that iterable. Now, here's the thing. Max also has some nuance to it. It has this key argument. Now, let's say you were going through an iterable and you didn't want to compare the elements based on, well, the elements themselves, right? You wanted to send them through another function or called property of theirs, or you basically didn't want to compare them, but you wanted to compare them put through another function, and you wanted to compare the outputs of that function. And you could do that by passing in a function as the key argument. And every time it does a comparison, it will then compute the output of that function for each input, and then we'll compare the outputs when returning the max. So how can we exactly apply that to this problem? So one thing you should remember is that if you were to call max on a dictionary, it would return the largest key value. But that's not what we want to do. We want to return the key with the largest associated value. So that's where the key argument in max comes in. That's going to help us perform that logic. So let me just write out here on the side how we're going to approach this. So we're going to return max on, well, there's only one thing we're going to be looking through, right? The dictionary associated with the clause, and we can get that dictionary using. So I'm just going to move this back a little bit real quick. Yeah. So and we can get that dictionary using the abstraction that we were given. Get clothes called on closet. Cool. So that's part of it. That's the first blank. And now we got to figure out what we're going to put in key, right? The question is, what are we comparing? We're comparing the values. So we need some function that takes in each key in this dictionary and then outputs the corresponding value. And that is what's going to be compared and, maximized using this max function. Well, we can pass in a nice one-liner function using lambdas, which is something we learned earlier in the course. So lambda, we can pass in a lambda function here. And let's just call the input to the lambda item. That is the argument that it's going to be taking. So now and let's see, so each item, is going to be a key, right? Every time we cycle through this, or when we cycle through this get clothes of closet dictionary, we're going to be plugging in every key we go through into this item parameter here. And so knowing that, how can we get the associated value for each key that we go through? Well, then all we have to do is, if item represents a key, then we can just get that same dictionary, right? And then we can pass in, I'm running out of space a little bit here, but just this goes on to the next line. We just pass in items in square brackets. And what this essentially does is it will find the corresponding value to that key item in the dictionary. That's exactly what this does. And this is the full solution. So to summarize, I realize this can be a little confusing because it's all done in one line with like scary lambdas and stuff. But at a really fundamental level, all that's happening is you're calling the max function on this dictionary. And you want to go through the values. You want to compare the values instead of the keys. And you want to return the key with the largest associated value. And to do so, you pass this lambda here in for key. And recall that the way key works is that it compares the outputs of whatever function you pass in. And so the outputs of that function are going to be the values associated with every key passed into it. And so, yeah, that's how we arrived at the solution. Hope that helped, and happy studying.